Now let us understand how to write down the names of the coordinate compounds. That's why the heading is naming of coordination compounds. See, coordination compounds, I've written 3 examples. Now how these 3 are different is, like in this case the coordination, what you have to see first before naming them is that what is the situation the coordination entity is, because that is the most difficult thing we have to write down, because that's the this is the species whose name is very typical, that is to be written correctly. So in this case this coordination entity is an anion because it's written afterwards, after the cation. Here it is written first, so it's a cation, and here we don't have anything before and after this, so it means it's a neutral species. So your coordination entity can be anion, it can be cation, or it can be a neutral species. Now how to start this? We always start with, of course, a cation. When followed, we will leave a gap and then we will write down an anion. So the cation will come out as a one word, anion will be written as a one word, and if they both are there has to be a gap between them. Otherwise, there will be no gap in the name of the cation and the name of the anion, because any one of these can be your coordination entity. Now, how to write down the coordination entity? Coordination entity starts always with, I'm talking about how to write down the name of the coordination entity. So it's the same except one very simple difference which will come out or will come automatically when the different steps are taken into consideration. Like, so coordination entity's name always starts with the number of ligands. So we indicate the number of ligands by certain prefixes, like we use as di, tri, tetra, penta, hexa for normal ligands. And if the ligand name itself contains di, tri, tetra, etc., we use the prefixes like bis to indicate number 2, tris to indicate number 3, tetrakis to indicate 4, like this. So it begins with the number of ligands. Then we write ligand's name in alphabetical order, or it is the order in which they are written, because they are always written in their alphabetical order. And in this we have to remember, like, all E's has been changed to O. So your ide will become ido, your ite will become ito, and your ate will become ato. So like chloride will become chlorido, sulfite will become sulfito, and sulfate will become sulfato. So then they are written, and then after we write down metal atom's name, and here there is a difference. And if the coordination entity is cation, we write it like this, the simple name. And if the coordination entity is an anion, we write down the name of the metal atom, and then we put ate as a suffix to indicate that yes, its coordination entity is an anion. And then after this, at the end, we write oxidation state, and that too in Roman numerals, in simple bracket. One small thing, whenever we have a ligand whose actually number is indicated by bis or tris, it is always kept in simple brackets. So these are the general simple rules for writing down their name. Let us see how we will write down the name of these compounds which I have written as an examples in these cases. Like this compound will be called potassium. I have written cation first. I will leave a gap because cation is a very simple ion. Your anion is your coordination entity, which is a complex ion. Now its name begins with the number of ligands. It's 3, so we call it tri. C2O4 is called oxalate, so it will become oxalato, and then it comes alumi. But since this we can't call it aluminium, because here now this time your coordination entity is an anion, so we'll put a suffix ate to the name of the metal atom, so we'll call it aluminate. And what is its oxidation state is 3 plus. So we call it, we put 3 in Roman numerals and in simple brackets. So this is what is the name of this compound is. Now let us see in this, what is the name of this compound is. Since its coordination entity is the cation, so again it has to begin with the name of the cation. It starts with the ligand. Now the first ligand is your amine, whose number is 2, so we will write down diamine. Then we write down this ligand's name, which is, first we will indicate its number, tri-aqua, we call water as aqua. Then we have Cl, which is called chlorido. We will not leave, see we are not giving, I am not giving any gap because the name of the cation has to come out, to be written as a one word. So it's diamine, tri-aqua, chlorido. What is this cation is? It's called cobalt. We will not put 8 as a suffix because its coordination entity is not an anion. So it's simply written cobalt, then we'll write down its oxidation state, which is, this is plus 1, minus 1 is this one, so it is actually is plus 2. So we'll write down cobalt 2 bromide. We'll leave a gap and then we will write down bromide because bromide is your simple, is your anion which is present in this coordination compound. Then how to name this compound? This is simple, without any counter ion, without any cationic anionic species, so it's a neutral coordination entity. So its name will begin with the number of ligands, so it's called penta. CO is called carbonyl, we will call it iron, and its state, oxidation state is 0 because carbon monoxide is neutral, so its oxidation state is 0, so its name is pentacarbonyl iron 0. So this is how we write down the name, and you can practice more from the different sources.